In this video, let us try to solve some problems on a diagonalization of matrix. Let us take the first problem. Let A is equal to 2 cross 2 matrix. Elements are 1, 6, 5, 2. U is equal to 6 minus 5 and V equal to 3 minus 2. We need to prove whether U and V are eigenvectors of A. And we need to show that 7 is the eigenvalue of A, and we need to find the corresponding eigenvector. So initially we need to find the characteristic polynomial, that is A minus lambda I is equal to 0. So therefore I can write this as equal to A is 1, 6, 5, 2 minus lambda 0, 0, lambda. That gives you determinant of 1 minus lambda, 6, 5, 2 minus lambda. When I solve this equation, this is equal to 1 minus lambda, 2 minus lambda, minus 30 equal to 0. It reduces to the form lambda square minus 3 lambda minus 28 equal to 0. When you solve this, you get two eigenvalues. Lambda 1 is equal to 7, lambda 2 is equal to minus 4. Corresponding to eigenvalue lambda 1 equal to 7, we will try to find the eigenvector. It is A, that is 1, 6, 5, 2 multiplied by x1, x2 is equal to 7 times x1, x2. When I simplify this, I get x1 plus 6x2 is equal to 7x1. That gives you minus 6x1 plus 6x2 is equal to 0. So here it is x1 is equal to x2. We take the second equation, which is 5x1 plus 2x2 is equal to 7x2, that is 5x1 minus 5x2 equal to 0. Once again we get this as x1 equal to x2. So therefore I can write this as x1, x2 is equal to, it is x1, it is 1, 1. So I get the eigenvectors, I can write as 1, 1. Let me take the second eigenvalue, that is lambda 2 is equal to minus 4. It is 1, 6, 5, 2 multiplied by x1, x2 is equal to minus 4 x1, x2. When I simplify this, I get x1 plus 6x2 is equal to minus 4x1. So that gives you 6x2 is equal to 5 minus 5x1. Second equation, if I write 5x1, 2x2 is equal to minus 4x2, that gives you 6x2 is equal to minus 5x1. So I can write here x1, x2. If I take the value of x2 is equal to 1, if x2 value is 1, then x1 value is minus 6 by 5. Or I can write this, the vector, eigenvector of condition as minus 6 by 5, 1. Or it can be written as multiplying with 5, I get this as minus 6, 5. If I multiply with minus 1, I get this as 6 minus 5. So you can say that in this case, U is an eigenvector. U is eigenvector. And here corresponding to eigenvector, eigenvalue 7, we have got the eigenvector as 1, 1. Second problem, let A is equal to 3B E inverse and compute A to the power 4, given C 5723, B equal to 2001. Given A is equal to C, B, C inverse. A to the power n is equal to C, B to the power n, C inverse. So here n equal to 4, so A to the power 4 is C, B to the power 4, C inverse. B to the power 4 is given by 2 to the power 4, 0, 0, 1 to the power 4. That gives you 16, 0, 0, 1. So A to the power 4 is equal to C. C is given as 5, 7, 2, 3. C to the power 4 is 16, 0, 0, 1. And C inverse, inverse of C is 3, minus 7, minus 2, 5. When we simplify this further, we get 5, 7, 2, 3 multiplied by 16 into 3 minus 2 into 0. So 16 into 3 will give you 48 minus 7 into 16, 5 into 0. So 16 into 7, 3 into 0 minus 2, minus 7 into 0, 5 into 1, 5. When you further simplify this, you get this as 226 minus 525, 90 minus 209. This is the answer. We need to diagonalize the matrix A given as minus 1, 4, minus 2, minus 3, 4, 0, minus 3, 1, 3. First, let us find out the eigenvalues using the characteristic equation. A minus lambda I is equal to 0. This is equal to determinant of minus 1 minus lambda 4 minus 2 minus 3, 4 minus lambda, 0, minus 3, 1, 3 minus lambda. So simplifying this, we get the characteristic polynomial minus lambda cube minus 6 lambda square plus 11 lambda minus 6 equal to 0. Simplifying this, we get the eigenvalues as lambda 1 equal to 1, lambda 2 is equal to 2, lambda 3 is equal to 3. Let us try to find the eigenvectors corresponding to these eigenvalues. For lambda is equal to 1, the eigenvector can be found out A minus 1, 4, minus 2, minus 3, 4, 0, minus 3, 1, 3, multiplied by x1, x2, x3. It is equal to 1 into x1, x2, x3. Lambda is 1, so we have taken here as 1. Simplifying this equation, we get minus x1, 4x2, minus 2x3 is equal to x1. So you get this as minus 2x1 plus 4x2 minus 2x3 is equal to 0, which will give me minus x1 plus 2x2 minus x3 equal to 0. Let us take the second equation. Second equation is minus 3x1, 4x2 is equal to x2, which gives you minus 3x1 plus 3x2 equal to 0. So therefore, x1 is equal to x2. Let us take the third equation, minus 3x1 plus x2 plus 3x3 is equal to x3. That gives you minus 3x1 plus x2 plus 2x3 is equal to 0. So we know that x1 is equal to x2. So therefore, we substitute in this equation. We get this as minus 2 minus 3x1 plus x1. So we get this as minus 2x1 plus 2x3 equal to 0, which gives you x1 equal to x3. So we can write here the equation eigenvector can be found out writing like this: x1, x2, x3 is equal to x1, 1. Since x1 is equal to x2, it is 1. And since x1 is also equal to x3, it is 1. So the eigenvector corresponding to lambda equal to 1, that let me call it as v1, is equal to 1, 1, 1. Let us take the second eigenvalue, that is lambda is equal to 2. When lambda is equal to 2, we can write the equation A is minus 1, 4, minus 2, minus 3, 4, 0, then minus 3, 1, 3, multiplied by x1, x2, x3, that is equal to lambda is equal to 2 multiplied by x1, x2, x3. This will give me the equation minus x1 4x2 minus 2x3 is equal to 2x1. So that gives you minus 3x1 plus 4x2 minus 2x3 is equal to 0. Let us write the second equation. The second equation is minus 3x1 4x2 is equal to 0. Is equal to 2 times x2. So it gives you minus 3x1 plus 2x2 is equal to 0. Therefore, x2 is equal to 3 by 2 times x1. Let us take the third equation, minus 3x1 plus x2 plus 3x3 is equal to 2x2, which will give me minus 2x3 minus 3x1 plus x2 plus x3 is equal to 0. So simplifying this further, I get x3 is equal to 3 by 2 x1. So when I write it in the form of a matrix equation, x1, x2, x3 is equal to, here x1 it is 1 and x2 is 3 by 2 times, x3 is also 3 by 2 times. Or I can write this is equivalent to x1, 2, 3, 3. So the eigenvector corresponding to lambda 2 is equal to 2, 3, 3. Let me take the third eigenvalue. Third eigenvalue is lambda is equal to 3. So you get minus 1, 4, minus 2, minus 3, 4, 0, minus 3, 1, 3 multiplied by x1, x2, x3 is equal to, here the value is lambda equal to 3, x1, x2, x3. Let me write the three equations. Minus x1 plus 4x2 minus 2x3 equal to 3x1. We get this as minus 4x1 plus 4x2 minus 2x3 equal to 0. That gives you 2x1 with the negative sign plus 2x2 minus x3 equal to 0. Let me write the second equation. Minus 3x1 4x2 is equal to 3x2. That gives you minus 3x1 plus x2 is equal to 0. So therefore x2 is equal to 3x1. Third equation, minus 3x1 plus x2 plus 3x3 is equal to 3 times x3. So when I simplify this further, I am going to get this as minus 3x1 plus x2 is equal to 0. So therefore x2 is equal to 3x1. If I substitute these values, in the first equation, I can get this as, the first equation is 2 minus 2x1 plus 2x2 minus x3 equal to 0. Here I have minus 2x1 and x2 is equal to 3x1, so 6x2 minus x3 equal to 0. Therefore, x3 is equal to, here, which is x1. So x3 is equal to 4x1. So therefore, I can write the three equations. x1, x2, x3 is equal to x1. If it is 1, x2 is equal to 3 times x1, x3 is equal to 4 times x1. So therefore, eigenvector V3 is given by 1, 3, 4. Using this, I can write the P matrix corresponding to eigenvalue 1, it is 1, 1, 1. Corresponding to eigenvalue 2, I got the eigenvector as 2, 3, 3. Corresponding to eigenvalue 3, it is 1, 3, 4. The D matrix is given by, corresponding to first one is 1, 0, 0. Second one is 2. Third one is 3. This is the diagonal matrix. Thank you. In the next video, we will study special matrices.